What's up, young mathematicians? Thank you for stopping by here at Tau2Pi. I am Caesar the Tutor, and today we are going to be doing a couple of examples of evaluating compositions of functions with actual values. Remember that when we do this type of operation, we can do it in two different ways. We can either compose the function first and then plug in the value, or we can plug in the value to the innermost function and evaluate that first, and then take whatever value we get and plug it into the outermost function. When doing the first method, you have to take into consideration the domains of the functions, because sometimes when we compose two functions, something happens that changes the way one function looks, and it makes it seem like the domain and the range will be all real numbers when in fact it's not. When we evaluate the innermost function first, we tend to avoid these problems because we can see right away if an input is valid or not. However, doing the composition first allows us to evaluate multiple times. If they ask us to evaluate the same composition for 4 or 5 different values, then it makes sense to do the composition first so that then we can just plug in values and get our output. Now we're going to do an example where we actually have to evaluate for a number. This is from set 2, problem 3, HOT of 7. So we have H of t of 7. We will be using the same functions as before with the same domains and ranges as before to make this easier for us. Now there's two ways that I can do this problem. The first way I can do it is evaluate for t of 7. So I'm going to put it right here. Method 1. Evaluate inner function first. Okay? So for this case, we're going to say t of 7. So we're going to say t of 7 equals, so now we're going to take t and we're going to say the square root of 7 minus 2, which is equal to 5. The square root of 5. Now the second thing I'm going to do is I'm going to take whatever I got and plug it in for h. And now we say h of root 5 is going to be equal to 2 root 5 minus 3. And then this would just become h of t of x. 2 root 5 minus 3. The second method involves what we did before. First, compose the function, and then plug in the 7 and see what you get. So let's go ahead and do that here. H of t of x. So first we're going to do h of t of x, which is equal to 2x minus 3, and then, or 2 something minus 3. And then when we plug in t of x, we get root x minus 2. And we say that h of t of x equals 2 root x minus 2 minus 3. The advantage is that if we figure this first, if they tell us now evaluate for h of t of 5 or h of t of 10, we can just simply use the same expression over and over again. But let's go ahead and finish up. We have h of t of 7 because that's ultimately what we want. And that just means ultimately just take that and plug it in for x. So we say 2 root 7 minus 2 minus 3. And that's going to give us 2 root 5 minus 3. Let's take a look at this example from set 2, problem 5, g of t of negative 3. And we know what they're asking is g of t of negative 3. Now if we solve this problem by composing the functions first, let's see what that looks like. G of t of x, which is equal to g, and that's going to be x squared, so something squared plus 1 And that something squared is going to be t of x, and t of x is x minus 2. And this is going to give us x minus 2 plus 1, which is equal to x minus 1. Now, if you were to do a problem like this and ignore the domains and the ranges of everything, you would naively say that g of t of negative 3 is simply going to be equal to, this is x, g of t of negative 3 is simply going to be equal to negative 3 minus 1, which is equal to negative 4, and you would say, I'm done with this problem. Give me an A, teacher. But the problem is that when you compose the functions like this, you have to take into consideration the domains and the range. And in a previous problem, we figured out that even though this looks like a line, it doesn't have domain all real numbers. It has to take the domain of the innermost function. And the innermost function says that the smallest value it can take is 2. So therefore, this is not even a valid input for this function. So, if you were aware of all this, then you had to actually not even do any of this problem and simply say x equals negative 3 is not in the domain of g of t of x. But if you had done this problem the other way, by evaluating t of negative 3 first, you would have actually caught that right away. Because as soon as you try to say t of negative 3 equals, and then you take your t and you say square root of negative 3 minus 2 equals square root of negative 5, you know that's a problem. You know that t cannot give you that output if you test it out. But if we go back to the domain, we would have actually seen that right away, and we wouldn't even need to complete this problem, which is why it's important for you to remember how to find the domains and list them first so that you are aware of what your function is doing before you jump aimlessly into a problem. That is all for today's lesson. Thank you for stopping by. I hope you learned something. I hope you liked the video. If you did, please don't forget to hit the like button. Please don't forget to subscribe if you want to see more content like this. And if you have any questions, comments, concerns, or emotional outbursts, make sure you drop them in the comments below. Thank you.